All right, in this video we are going to be tackling 2.1.3. Big question of the day is how steep is it? Comparing change in x and change in y. All right, as we're going through today, I want you guys to keep some important questions in mind. Number one, how can we tell whether a slope is positive or negative? Number two, what makes a line steeper and what makes a line less steep? And number three, what does a line with a slope of 0 look like? All right, let's go ahead and start moving through our lesson here. I want to start with number 25. And please read through this and answer the question. Picture yourself climbing or descending the stairs from left to right on each of the lines on the graph shown below at right. Of lines A, B, and C, which is the steepest and which is the least steep? So I want you to look at lines A, B, and C. A, B, and C. And I would like you to pick which of those three lines is the steepest and which is the least steep. So have a look at A, B, and C. Think about yourself walking along the line from left to right. It looks like we're going to be climbing a hill for those two. Looks like we're climbing a hill for this one also. So picture yourself going up these hills. Which one would be the steepest hill to climb? Which one would be the least steep? And write your guesses down there. We're going to come back to this and find a numerical way to tell which one's steepest and least steep, but go ahead and write your guess down right now. Okay, we're looking at part B now. We'll come back to A in a moment. Let's look at B. So this says examine line D, so I'm focused on this one here. It says, what direction is it traveling from left to right? Imagine yourself as a person on this line and you're walking from left to right. Which direction are you traveling? Are you going up or are you going down? So from left to right on that line, I would be walking downhill. So which direction? We're going down. It says, what number should be used for the change in y to represent this direction? Let's look at our slope triangle here, and we said we can pick any slope triangle we want to. I'm going to go ahead and highlight this one here. And I'd like you to look at this and think about change in y. Delta y would be my change in y. That's how far I'm going up or down. What number do you want to use for this? I'm counting 2 spaces. Should we use 2? Or should we change that since we're going down? Well, it turns out since we are going down from left to right, we're actually going to use a -2 for our change in y here. If I were walking along this line, I would actually be going down 2 as I walked along. All right, part C is asking us to label the slope triangle on each of the lines and then find the slope. All right, so this is what's going to help us go back and answer part A about the steepest and the least steep. So let's go ahead and go through and do that. We're going to start with line A. Let's just remind ourselves off to the side here what the slope is. Slope is equal to the change in something over the change in something. Do you remember which one goes on the top? Change in what over change in what? Sometimes my students like to think of rise and run. We know it's rise over run. What's the rise? Is that the y direction or the x direction? Rise goes with y's. Run goes with x. So change in y over change in x. So let's go ahead and do that. Let's do it for line A first. I'm going to set up my fraction here. My change in y over change in x. Again, I can pick any slope triangle I want. I'm going for that one right there. My change in y is 1. We're going up 1. And my change in x is also 1, up 1 over 1. And let's simplify that. We don't need a calculator to figure out what 1 divided by 1 is. It is 1. Moving on to line B, pick any slope triangle you like. I'm going for this one right here. All right, my change in y over change in x. Change in y, 1, 2, 3 spaces, and my change in x is 1. So change in y over change in x would be 3 over 1. 3 divided by 1 is 3. So my slope there is 3. Now let's pause for a second here. Which one's steeper, A or B? Well, we can tell visually that this is definitely steeper than this. Can you see numerically that it's steeper also? This number is bigger than this, which means that it must be steeper. All right, we're moving on to line C. Let's pick a slope triangle. This one's sticking out at me. I'm going to pick that one. Let's do change in y over change in x. My change in y is 1. My change in x is 2. So change in y over change in x would be 1 over 2, which is a half. If we wanted to express that as a decimal, that would be 0.5. All right, it is now time for us to go back and answer part A. Which of these lines is the steepest? Well, we can tell numerically because the steepest line should have the biggest slope. As I'm looking at these numbers, the biggest number that I see is 3. So B is my steepest line. And which one is the least steep? The least steep line would be the one with the smallest slope value, which in this case is 0.5. That means that C is the least steep. Is that what you had when you answered part A before? If not, go ahead and make those changes. All right, we've got one more to do here, and that's line D. We've already started forming its slope triangle right here. We said that the change in y was -2. And let's see what our change in x is. 1, 2, 3, 4, 5 spaces. My change in x is 5. So -2 over 5. We could leave that as a fraction, -2 over 5. We could put that into a calculator. -2 divided by 5 is -0.4. All right, part D asks us, how does the slope relate to the steepness of the graph? I'd say the bigger the slope, the steeper the graph. All right, let's look at part E here. Cora answered part D with the statement, the steeper the line, the greater the slope number. Do you agree? And then it tells us to look at lines A through D to support. This is making me believe that maybe our answer wasn't correct. I'm not sure because we sort of had the same answer. The steeper the line, the greater the slope number. That's the same thing we've got here, just backwards. Let's go back and see. And what I want you guys to focus on right now are lines C and D. Now, these two lines are different because one's going uphill and one's going downhill. But I want you to answer the question, which one is steeper, line C or line D? It's kind of hard to tell to me when I look at it. They both look like they're about the same steepness. But let's look at the number for the slope. Notice that line C has a slope of 0.5 and D has a slope of -0.4. If we ignore the negative, which of those two numbers is bigger? Let's say the 0.5 is bigger. That means that line C is a little bit steeper, not very much, a little bit steeper than line D. So when we're looking at the slope and we're trying to figure out which one is steeper, we can still look at the number, but we could also ignore the negative on it. So I would say to answer this question, look at the number, but ignore the sign on it. If you're just looking at steepness, the sign doesn't tell you how steep something is. It's the number that comes after the sign. So we can ignore the negative and just look at this as a steepness of 0.4. This would actually have a smaller steepness than C. Okay, moving on to our next page. So they're asking us to do the same thing here, find the steepest line. So I'm actually going to suggest that we go ahead and skip down to part C and do slope triangles and then find the slope for each. So I'm going to encourage you to do part C and part D on your own right now. And then we can come back and answer parts A and B once we have those slopes. So if you are feeling comfortable, please pause the video right now. Go through and do your slope triangles for each of these 5 lines. And then find the slope for each one. And then come back and check your answers. If you're not quite so sure, I'm going to work through some lines. I would encourage you to watch me work through a couple. As soon as you're feeling comfortable to do it on your own, again, please pause and try and do the problem on your own. All right, I'm going to focus on line A, and I'm going to pick a couple points and do a slope triangle. I think I'm going to pick these 2 points. So my slope triangle is going to be here. My change in y is 2. My change in x is 1. So let's find our slopes. I'm just going to rewrite that slope equals change in y over change in x. Why do I keep rewriting this over and over again? Because repetition is what's going to help me learn long term. All right, we're looking at A. We said change in y was 2, change in x was 1, and we are going uphill here, so this would be a positive 2 over 1, which is 2. So we got our slope for line A. I'm going to do line B next. We'll go ahead and set up my fraction. I need a slope triangle. I'm going to pick these 2 points right here. So let's find some change in x and change in y. It's kind of hard to see. I'm going to highlight my slope triangle there. So change in y, I'm going up by 1, 2, 3. And my change in x is 2. So 3 over 2. And I could leave that as a fraction or change it to a decimal. Either way is fine. Go 1.5. Now, if you're feeling confident after watching those 2 examples, please try and do the slopes for C and D and E on your own. I'm doing C next. I need to pick a couple points. I think that I will go with, let's see, let's do this one and this one. So my slope triangle would look like this. Change in y, let me get my fraction set up. My change in y is 2, my change in x is 3. So I've got 2 over 3. Now this one, if I put this into my calculator, 2 divided by 3 to get a decimal, I'm going to get that, which is a non-terminating decimal. So that is not, I cannot round that off, or I'm going to change the value of it and it won't be 100% correct. So if it may be helpful to look at the rounded decimal, but I'm going to change my equals to the squiggly equals, which means it's not exactly this, but it's pretty close to, and let's round it off to a couple decimal places. So 0.6, and should I change this 6 to a 7 or leave it as a 6? It depends on the next number, which is bigger than 5, so we'll change that to a 7. So that's about 0.67. The squiggly equals means it's not exactly that, but it's close to it. If I wanted an exact value, I would need to leave this as a fraction. All right, there's that triangle. Next, they want us to do D. All right, now what I noticed about D is when I look at my slope triangle, this one's going downhill. As I walk from left to right, I'm going downhill this time. So when I do my D slope, I'm going to have a negative change in y. I'm actually going down by 1, so negative 1. And then my change in x, I'll count here, 1, 2, 3, 4, 5. Negative 1 over 5. Will that give us a terminating decimal? I believe it will, but let me check here. Negative 1 divided by 5 is negative 0.2. So I can use an equals because it is exactly negative 0.2. And finally, our last one, E. Now this is a weird one because line E, as I look at it, it's not going uphill or downhill. I don't see any more points that I could draw. I could draw a triangle between these 2 points, but how can I draw a triangle? If I look at those 2 points, my change in x is 1, 2, 3, 4, 5 spaces, but my change in y from here to here, it doesn't go up or down, so it would be 0. 0 divided by 5 is 0, and the slope of line E would be 0. That was one of our questions for today. What does a line with a slope of 0 look like? Answer that question for me now. What does a line with a slope of 0 look like? Well, it looks like that. It's a flat horizontal line. All right, going to answer these next two kind of quickly because I want to move on here and get some examples in. So let's look at part E. This says, viewed from left to right, what direction would a line with a slope of negative 3 over 5 point? Now, the fact that that has a negative 3 over 5 means that that line is going to be going downhill. It's going to be moving downhill. I know that because of that negative right here. That negative tells me that as I move from left to right, I'm going downhill along this line, which means if I wanted to do a slope triangle for it, my change in y is going to be negative 3, and my change in x is going to be 5. So from left to right, we would say this is going downhill. And how do we know? Because of the negative. Question F asks us, viewed from left to right, what direction would the line with the slope of negative 5 over 3 points? Now it says a negative there, so I think it's still going to be going downhill. Let's see what would change this time around. We'd still be walking downhill from left to right. Our change in y over change in x this time, though, it's going down by 5 and over by 3. So it's still downhill because of the negative. How's it different from this line? The change in y and the change in x kind of flipped. I've got another question for you. Which one of these would be steeper? They're both going downhill, but which one would be steeper? Now, I did not draw these to scale. This 5 should be quite a bit longer than this 3, and they look about the same time and size. And here, this 5 should be longer than this, and this looks longer. But if we actually looked at some numbers, which one is steeper? Which one's going to give us the bigger number? The negative 3 divided by 5 or the negative 5 divided by 3? Which one's going to be a bigger number? I would say if I'm just looking at the fraction, that 5 divided by 3 is going to be bigger than 3 divided by 5. If we were talking money, I would rather split $5 up evenly between 3 people than trying to split $3 up evenly between 5 people, because this is going to get more money per person. So I'd say this one is steeper. All right, last question on this sheet. What happens to the slope when the triangles are different sizes? We kind of already talked about this in the last lesson. Do you remember? I'm going to pull up something from our last lesson. Do you remember when we were talking about how it did not matter which points we chose to find the slope? how the slope always ended up being the same value. So this question's getting back to that same idea. Does it matter whether I choose this point and this point to find the slope, or whether I choose this point and this point, or whether I choose this point and this point? Is that going to change anything about the value of the slope? And the answer is no, it should not. Let's just go ahead and find those slopes and just verify this for ourselves. For this first one, my change in y, we're going from 2 up to 5. From 2 to 5, I'd say that's 3. And my change in x goes from 0 to 6, that's 6. So one of my slopes is 3 over 6, which reduces to 1/2. Let's look at this itty bitty triangle now. This one they drew above the line, which is totally legal. We're allowed to do that. The change in y here is just 1. My change in x, this goes from 2 to 4. 2 to 4, that's a change of 2. So change in y over change in x is 1/2, which matches the slope that we got just a moment ago. And let's do one more. My change in y here, this lines up with 5, and this lines up with 7. From 5 to 7 is 2. And then my change in x, my x is going from here to here. That's from 6 to 10 in the x direction, which is 4. 2 over 4 reduces once again to 1/2. So does it matter where we draw our slope triangle? The answer is no. We're going to get the same slope no matter what. Okay, thank you so much for your attention.